Hello and welcome to the Flow Developer course. The goal of this course is to teach you more advanced flow development topics. In the Foundations course, we covered the basic building blocks for conversations, but there were many real-world scenarios that we still can't build without learning more. It's fair to say that this course will take your flow development skills to a whole other level, and you should leave confident that you can tackle many common scenarios. For the most part, this course does not require writing code, though I do introduce more technical concepts. The ideal audience is anyone from a courageous business user with an analytical mindset to a skilled developer. To start things off, in this session, we'll pull back the curtain and learn about the input and the context. These concepts are important. They are fundamental to building real-world flows, so you'll want to pay particularly close attention to these topics. To start learning about the input and the context, I need to give you a proper introduction to the interaction panel. So far, we've used the interaction panel to test out our flows. We turned on expert mode to see feedback like intents and slot matches. And we used our favorite shortcut, Control-B or Command-B, to clear the chat window. But there's much more to the interaction panel. I'll show you a few features we haven't looked at yet in the chat view. At the top, we can select a snapshot. We'll cover snapshots later in this course. For now, know that it's like a versioning mechanism for your agent, so you could test your conversations using a version of your agent from last week versus this week. A real-world example would be testing a conversation on the production version of your agent versus a work-in-progress version of your agent. Below the snapshot field, there's a field that lets us choose the starting flow for our conversation. We haven't talked about working with different flows yet, but the more flows you have, the more you may want to test out different flows without having to leave the view of the current flow. So I can start the conversation here in my main flow, or I could point the interaction panel to any other flow in this agent. Next to the drop-down is a vertical ellipsis that gives you the option to clear the chat, the same as pressing Control-B or Command-B. You'll also see the option to create a playbook, a topic that we'll cover later in this course. Below this drop-down, you'll see Chat, Info, and Settings. I'll refer to these as tabs, i.e. the Chat tab, the Info tab, or the Setting tab. Let's go over to the Settings tab. We've seen the expert mode toggle already. That gives feedback on intent matches and slot matches, among other things. Beneath that, you can choose the channel you want to display. This is helpful if you've configured channel-specific output, but for testing purposes, you only want to see the default channel in the interaction panel. It doesn't affect the flow functionality. It can just make the interaction panel easier to read if you have multiple channels configured. The other options here relate to features that we'll learn about later, but for now, I'll just note that you can configure how the interaction panel runs playbooks and change the input mode to let you select a playbook. Things get exciting when you go to the Info tab. This reveals 4 subtabs for the input, state, context, and profile. You may be wondering, what am I looking at? And how technical do I have to be to make sense of it? Don't worry, we'll take it one step at a time, and I'll share some useful tools so that both coders and non-coders can feel comfortable. To get started, I'll create a new flow. I'll call it Interaction Panel. I'll add a couple of question nodes. Did you enjoy your flight? This is a yes/no question. I'll save the answer to the Cognigy context and make the context key be something descriptive like satisfied. I'll add another question and make it a text question. What was your flight number? I'll save this to the context as flight. Now I'll add a say node to output the flight number. Your flight number is last question result. Now let's run through it. The questions worked fine, but Cognigy didn't output the last question result. We'll learn why that is in detail, but for now, that's because we're storing the answer in the context rather than in the input. Where can you see the context? I'll go to the Info tab and then click on Context. There I see two values, satisfied and flight. Those reflect the keys I specified in the question nodes. For the first question, satisfied, I said yes. Cognigy stores the yes-no answers as true or false. For the flight, you'll see the flight number I entered in quotes. This particular structure, with the open curly brace at the top and closing curly brace at the bottom, is called JSON, or JavaScript Object Notation. But you don't need to know JavaScript to work with it. You can just think of it as an outline, a hierarchical list with each element separated by a comma. I can access these values in my say node. I'll delete last question result and replace it with opening and closing double curly braces, like this. These curly braces just tell Cognigy that I want to insert some dynamic content. Between the braces, I'll put context.flight. This tells Cognigy to look in the context object and output the value for flight. Now if I go through my flow, I see the flight number output at the end. I also want to tell the user if they were satisfied or not. Under my say node, I'll add an if. In my condition, I'll switch over to the advanced editor and enter context.satisfied. This just means if context.satisfied is true, then do something. I'll add say nodes to reflect whether the user was satisfied or unsatisfied. In the say node, I use context.flight to output the flight number. In my if node, I check if context.satisfied is true, and if so, let the user know that they are satisfied. Let's try the no scenario. Here, context.satisfied is not true, so it goes down the else branch. This is really important to understand. So if it's not clear, take a moment and try it out yourself. I'll open my if node and look at it again. Cognigy checks the satisfied value in the context. If it's true, Cognigy follows the then branch. If it's false, Cognigy follows the else branch. And if I look at the context, I see those values. Now let's make it one step more interesting. In my question nodes, I'll go under Advanced and select Store Detailed Results. I'll go through the flow again. Now it says your flight number is object. That's not what we're looking for, so let's examine the Cognigy context to figure out what happened. The context now has much more information. On line 2, you'll see satisfied, and on line 10, you still see flight. But there's other stuff here that we need to understand. To help visualize this more easily, I'm going to use a tool called JSON Pathfinder. You can find it at jsonpathfinder.com or just search for it online. There are other similar tools that you can find if you search for JSON Formatter, for example. Many tools do the same thing, but this is the best one for our training. I'm going to copy the JSON from the context into the left side of the JSON Pathfinder. Now look what we see on the right. We see our answer keys, satisfied and flight, with some arrows next to them. If I click on the arrow next to satisfied, I see some additional information. I see the value as true. I see the timestamp when the user responded, and I see that their actual answer was yes. If I click on the arrow next to question, I see the actual question. Did you enjoy your flight? Again, think of this as an outline with categories, subcategories, and so on. Let's collapse satisfied and look at flight. There I see the same fields: value, question, timestamp, and answer. So if I want to output the value that the user entered, I need to use that field called value. And here's why I like this tool so much. If you click on value, you'll see the path to that value in the path bar. Take a moment to think about this. The path describes the hierarchy to reach the value. So it starts with X, which in this case is just the top level, and then it goes to flight, and then it goes to value. So the path represents the hierarchy of our outline. I'll click copy. Now I'll go to my say node and replace context.flight with x.flight.value. I'll change the x to context because that's where the value lives. So I have your flight number is, within double curly braces, context.flight.value. Now if I go through the flow again, it outputs the flight number correctly. We need to make this change to our if node as well. I'll go back to my JSON Pathfinder tool and find the value in the tree on the right. I'll click on the value under satisfied and then click copy. Again, I'll change the X to context. And now we're all set. Two questions come to mind. One, is it necessary to enable store detailed results? It's not. That setting could be helpful if you want to use those values later in the conversation, but it's really just an example of a more complex JSON structure that we could examine. Two, why store things in the context? The idea behind the context is that you often want to collect information from a user and make it available later in the conversation. So if the user asks for the status of flight UA277, we should remember that. Later in the conversation, if they ask us what baggage carousel they should go to, we shouldn't have to ask for their flight number again because it's already in the context. Let me give you an example of that. I'll add a question node to the bottom of my flow that says, "What was your flight number?" I'll just copy the question I already asked at the beginning of the flow. I'll also copy my say node that outputs the flight number and put it at the end of my flow. If I test it out, I have to answer the question about my flight number a second time. We can imagine that this is at some other point in the conversation where I've triggered a different intent that requires this information, for example. Now I'll make a small change to my question node. Under context, I'll select Skip if answer exists in context. Now I'll run through it again. Now it makes its way to the end of the flow without asking me the flight number again. That's because I've stored the flight number in the context, and I've told Cognigy to skip the question if we already have the answer. Hopefully that gives you a basic understanding of how to work with values in the Cognigy context, and how to interpret or work with the context JSON. Now we'll look at the input JSON, which is longer and much more rich in information. I'll create a new flow and call it input. And I'll upload the intents that we created in the Foundations course. I'll enable my baggage lexicon and then train. I'll clear out my chat and say, can I bring my backpack on board? I have 2 of them, to start the conversation. If I go to the Info tab and the Input sub-tab, I see a lot of information. I'll copy that over to JSON Pathfinder to make it easier to read. Once you get used to reading the JSON body, you might not need a tool like this, but it's really useful for learning, and you might refer to it in the future for complex JSON bodies. On the right, at the top, you see the text the user entered, which was, can I bring my backpack on board? And you see much more information. Below the text, I see the intent that was triggered, baggage rules carry on, and I can see the intent score. If I click on slots, I can see there was a number match and a bag type match. I can drill all the way down into the number and see the number 2 because I said I have 2 bags. I can drill all the way down on the bag type slot and see the key phrase match for backpack. There's a lot more here, and we'll look at other branches of this tree later on. Let's look at how we can use this information in our flow. Let's check the user's intent and let them know we can help them with their bag. If you'll recall from the Foundations class, we can create a lookup node which checks for intents. I'll create a lookup node and set each case node to handle an intent. For my carry-on bag intent, I'll let the user know we can help them with their bag. I'll create a say node that says, I can help you with your, and then I'll put my double curly braces, 2 open braces and 2 closed braces. In between them, I want to put my slot match. I'll go to my JSON Pathfinder and click on the backpack key phrase. I'll copy the value and put it into my say node. Since we're working with the input now and not the context, I'll change the X to input. Now I'll say, "Can I bring my backpack on board?" And the bot recognizes my intent and responds with the correct slot match. I could also say, "I need to bring my messenger bag on the flight." And Cognigy finds the slot match again. A thing to remember about the input is that it only exists for each input and then goes away. To persist information, we need to store it in the context. So that's what I'll do. Under my carry-on node, I'll add an if. I want to check to see if there's a slot match for bag type. To do that, I'll go to my JSON Pathfinder and click on bag type. I'll copy that and paste it into the condition field. I'm looking for the slot match in what the user just said, the input, so I'll change the X to input. And then I'll choose Exists from the dropdown, so I'm checking to see if there's a bag type slot match of any kind. If there is, I'll move my say node to the then branch and let the user know I can help them with their bag type. The other thing I want to do is store the bag type in the context, so I don't have to ask them about it again. Under my say node, I'll add an add to context node. For the key, I'll put bag type. For the value, I'll add the full path to the bag type. If I go to my JSON Pathfinder, I'll drill all the way down to the bag type key phrase. I'll copy the path and paste it into the value field. Don't forget to put this path between double curly braces. Because we're getting this information from what the user just said, I'll change the X to input, and I'll click Save. Let's test it out so far. I'll say, "I need to bring my messenger bag on the flight." Cognigy responds as I would expect. But did it save bag type in the context? Let's take a look. If I click on Info, then Context, I can see that messenger bag was successfully stored in the context. If the user didn't specify a slot type, I want to ask them. In my else branch, I'll add a question node that says, "What type of bag will you be carrying?" I'll make it a slot question, specify bag type as the key, and I'll store the answer in the context. Let's keep using bag type as our key. I'll move my say node under the then and else branches, so the logic works like this. If the user has mentioned a bag type, I'll add it to the context and say, "I can help you with whatever bag you mentioned." If you didn't mention a bag, I'll ask you what type of bag you're bringing, and then the same say node will execute. Let's try it. I get my expected confirmation message, and if I look at the context, I see the bag type. If I say, "Can I bring my ski bag on board?" Cognigy gives me the confirmation message, and I can check the context to confirm the add to context node worked as expected. As one more improvement to the flow, I want to ask the user about their bag if they asked about check bag fees. I'll add an if under the checked bag branch. I'll check in the context to see if the bag type exists. Remember, we're getting this out of the context, not out of the last user input. In my if condition, I'll put context.bagType, and I'll choose exists as my operator. If there is a bag type in the context, I'll let the user know I can help them. I'll copy the say node from the other branch. Between the double curly braces, I'll just reference the context value, context.bagType. Similar to the other path, I'll ask about the bag type if they haven't mentioned one. To make it easy, I'll copy my question from the other branch. I'll change the text to say, what type of bag will you be checking? So at this point, we either remember the bag type from a previous question, or we ask the user explicitly. Let's imagine we want to give a different response depending on the bag type. If they have a ski bag, it needs to be handled as an oversized bag. If it's a backpack, we'll tell them they could take it as a carry-on. If it's anything else, we'll tell them they can check the bag for free. To do this, we'll add a lookup node. You may be surprised to see this. Aren't lookup nodes for checking intents? By default, yes. But you can actually use lookup nodes to check for other things as well. I'll open the lookup node, and on the type field, I'll select Cognigy script. For the operator, I need to tell Cognigy which value to look at. In this case, it's going to be the bag type. This value should exist at this point in the context, so I'll just put context.bagType. For my first case node, I'll put ski bag, and for my second case node, I'll put backpack. I'll put a say node under the ski bag branch, and say, ski bags are considered oversized and require special handling. Under the backpack branch, I'll say, you can check your backpack or just bring it on board. Under the default branch, I'll put another say node and let users know they can check one bag for free. What's happening here is that Cognigy is going to look at the bag type value in the context. If it's a ski bag, they will get one message. If it's a backpack, they'll get another, and if it's neither of those, they'll get the default message. Don't forget that I can add as many case nodes as I like. Let's test it out. Can I bring my ski bag on board? How much does it cost to check a bag? Let's take a step back and think about what we've learned. 1. We've learned that Cognigy stores the input values and the context values in a hierarchical structure called JSON. 2. We can access those JSON values using the keyword input or context, followed by the path in the JSON. 3. We saw that by storing values in the context, such as slot matches, we can remember those values across multiple turns in the conversation. 4. And finally, we saw that we can use a lookup node to give different outputs based on the value of an item in the context. Let's look at another example of how we can use the Cognigy input to give intelligent answers to our users. Our goal is this. We know that you can't bring just anything you want on an airplane. Every country has its own rules around how much liquid you can bring, how to handle sharp objects like tweezers or scissors, and how to manage unusual items like musical instruments. I want to create a bot that lets users ask about different things they want to bring and whether or not they're allowed on a plane or in checked baggage. For unique items, I want to give explanations as to how or why they need special handling. If you could connect to a database with this information in it, you could simply query that database, and we'll learn how to do that later in this course. But what about business information that's important and doesn't change frequently but doesn't live in a database? Think of things that you might have in a spreadsheet on your intranet or in a list or table on a website, but haven't risen to the level of importance to put them in a system that can be easily queried. This happens more than you might think. In Cognigy, there are different ways you can address this. Cognigy isn't designed to be a replacement for a database system, but for small-sized datasets, there are some interesting approaches you can take. The goal of the following exercise isn't to persuade you to use Cognigy as a database. It's to show you an additional feature of lexicons and to get some more practice working with the Cognigy input and the Cognigy context. I've downloaded a list of 452 items you might bring on a plane and their related rules from the U.S. Transportation Security Administration website. I converted the list to a CSV file and uploaded it as a lexicon in Cognigy. The other thing I did was to append data elements to the lexicon. For example, if I search for tweezers on my list, and I click the down arrow on the right, I see some additional information. I see an explanation for what makes tweezers unique. They're potentially sharp objects, and I added two values, carry and check. Carry indicates whether the item is approved as a carry-on, and check indicates whether the item is approved to be included in checked baggage. Some don't have explanations. If I search for a thermometer, for example, I see that it can be a carry-on item or a checked item without further discussion. Let's see what happens when I use this lexicon in a flow. I'll go back to my flow and make sure that I've attached the pack lexicon. In the interaction panel, I'll just enter tweezers. Let's look at the Cognigy input. I'll copy it to the JSON Pathfinder to make it easier to read. If I drill down into slots and then pack, I'll see the key phrase match for tweezers. Now let's drill into data. Here I see the fields with the explanation and the indicators for carry and check. Let's use this in our flow. The first thing I'll do is create an intent that uses my PAC lexicon. I'll call it baggage rules permitted items, and I'll add some example sentences and annotate them. After I'm done annotating, I'll save and build. In my chart, I'll add a case note and reference my new intent. Let's think this through. If the intent is triggered, I want to see if the user has already asked about a permitted item. If they have, I'll let them know if it's approved for carry-on or check-in, and I'll provide an explanation if one exists. If they haven't mentioned which item they're concerned about, I'll ask them. In either case, I'll store the item they're asking about in the Cognigy context. So first, let's check if there's a slot match for the PAC slot. In my condition, I just need to check if the slot exists. I'll go to my Pathfinder and click on PAC, and then copy the path. I'll paste it into my condition. Because I'm getting this information from the input, what the user just said, I'll replace the X with input. If the PAC slot exists, I'll share the rules with the user. I'll check to see if carry is true, and if so, let the user know. I'll repeat that for check. I'll create an if node, and for the condition, I want to see if carry is true. In my Pathfinder, I'll drill all the way down into my data branch and click carry. I'll copy that and paste it into my condition. I'll change the X to input. For the condition, I'll put is yes. You may recall from an earlier session that Cognigy treats yes as true in this case. So, if carry is true, I'll tell the user they're allowed to bring the item on board. I'll create a say node for the then and the else branches. I'll repeat this again with checked baggage. I'll copy my if and make the necessary changes to the if and say nodes. Finally, I'll output the explanation if there is one. I'll create a say node and add my double curly braces. I'll go to the Pathfinder to get the path to the explanation. I'll copy it and paste it between the curly braces. Because this is coming from what the user just said, I'll change X to input. You'll notice that I didn't add an if here to check to see if there is an explanation. I decided that if there is an explanation, we'll output it, and if there's not, Cognigy won't output anything, which is okay. The last thing I'll do is add the slot match to the Cognigy context. I could use an add to context node like we did before, but I have an even easier option, which is to add the slot match to the context using the copy slots to context node, and it will do just that. I'll need to tell it which slot to copy and which context key to use. Now if I go all the way to the top, I can see that I first check if the slot match exists. If it does, then I go through all the logic I just created. If it doesn't, I need to ask the user which item they're concerned about. I'll add a question node with a question type of slot. I'll use pack as the slot name to look for, and I'll ask the user, which item are you concerned about? Now what? Do I need to reproduce all of the logic I have in the then node, or is there a way I can make use of everything we just created? There are a couple of ways to handle this. I'll show you a new node type that can help. Under my question node, I'll add a think node. Think nodes let you send an input into the flow as though it came from a user. So if the user answers my question with Xbox, I want to send an input to the flow that says, "Can I bring my Xbox?" as though the user said it themselves. This will trigger my intent and bring a slot match with it. In my think node, I'll put, "Can I bring my?" and then I'll add my familiar token last question results. Let's see how it works. You can see that the bot responds as expected, and if I look in the context, it copied the slot match to the context. Now I'll ask, I need to check if an item is permitted on the plane. Great, everything is working as expected. So what we learned here is how to store additional data in your lexicons and how to use that data in our responses to users. I want to implement one more scenario as our final practice exercise in working with the Cognigy context. Thinking back to our checked bags intent, I want to ask a user a question prior to sharing the baggage fees. I want to ask if they're a premium gold member or higher in our frequent flyer program. I might do this with a yes/no question. But what if the user isn't sure? I need to implement logic that accepts yes and no, but also maybe or I'm not sure. So if the user gives something other than a yes or no answer, I'll tell them they can log in to find out. As a reminder, here's how our checked bag flow works. Is there a fee to check a bag? But before I tell the user they can check one bag for free, I want to ask if they're a Premium Gold member. So on this default branch, I'll ask my question. I'll create a question node that says, "Are you a Premium Gold member?" If I were to make this a yes or no question, Cognigy would only accept yes or no as an answer. So I'll make it a text question that will accept any response. Under the question node, I want to respond differently based on the user's response. How can I detect yes or no, given that this isn't a yes or no question? We can look in the input for clues. I'll just enter yes into the chat. I'll copy the Cognigy input to my Pathfinder. If you look a few entries down the outline on the left, you'll see an attribute called type, and the value is p-answer. That stands for positive answer. Now I'll go back to the chat and try the same thing with no. When I copy the input back to the Pathfinder, I see the answer is now an answer. That stands for negative answer. Finally, if I try the same thing with I'm not sure, I see the type is statement. So let's use this information to respond differently to the user based on what they say. I'll go back to the chart and create a lookup node. I'm creating a lookup node because there are 3 possible values: positive answer, negative answer, and something else, like a statement. On my lookup node, I'll change it to Cognigy script. For my operator, this is the value I want Cognigy to examine, I'll add the type field. I happen to remember that this is just input.type, but you could also get that from the Pathfinder. Just remember to change the X to input, since we're getting the type value from the input. In my case nodes, I'll make one p-answer and one n-answer. If the user is a Premium Gold member, I'll tell them they can check a bag for free. So I'll just drag my say node under the p-answer node. Under the n-answer node, I'll add a say node that says, checked bags are an extra $50 each. And if they say something other than a positive or negative answer, I'll tell them to please log on to the portal to check your membership status. All right, let's give it a try. Now let's try again. That concludes this session. I hope you've learned a few things. 1. how to find the input and context information in the interaction panel. 2. How to interpret the input and context with the help of JSON Pathfinder. And 3. How to use the JSON notation in if, lookup, and say nodes to make more intelligent conversations. If you feel uncertain around how to access values in the context or the input, take some time to practice, as this is an important skill for building more complex flows.